Okay, this demo is to show the Monogame hot loading system, the new and improved version. So the motivation here is to provide something like you would get from a scripting language, but you're able to just use C# as you normally would, such that you can have a game or application running and completely change the code, rebuild that code, and have the game or application continue running from where it was with that new logic in place. So for this demo, we have a very simple game with a character. We can move back and forth and jump up and down. And so right now, if you're moving, you can't jump. All right, that's part of the logic. So if we go here to the game state, actually I'm going to open up a second Visual Studio here. This is just one way to work with it. So this game logic project represents kind of where all the logic for your game is, both update and drawing in this case. And here we have some constants like the movement speed. So we can change that, and we'll do a build. And once it's rebuilt, the game now has a faster movement speed. That by itself is not so interesting, since you could have a configuration file that you watch and just update settings when the configuration file is changed. One advantage to this, though, is you can make things const, which lets the compiler optimize them more than they would if it was a variable that you set from a configuration file. But more importantly is you can actually change logic in your code arbitrarily, not just setting values in a configuration file. So down here, for instance, if we take out this else, we can let the player jump whether or not they're currently moving. So we can save that, build it, and now you can move and jump at the same time. And the way this is set up with Monogame, you could use this with any C# application, but this is set up to work with Monogame. Both your update logic and your drawing logic can be in a separate DLL that you can change however you like, and the program will keep running. And you'll notice when I do a rebuild, I'm going to move the player over to the far left. When I do a rebuild, if I change something again, let's go back to the slow movement speed. It's not starting the whole program over, right? The program is still running in the current state it was in before, but now with a new code where movement is slower. And that is nice because if you're, say, deep into your application or game, you know, say level 3, halfway through it, and you want to tweak something about that level, you can do it without having to restart or reload a save game or something. So you can do it very fast. So how does this work? Let's go back to the first Visual Studio. So you have all of your sort of game code in a game logic project, and then you have what I'm calling the platform layer in a separate project. So pretty much all the platform layer does is call into your game logic and watch the file system for updates. So this hot loader class does most of the work. It keeps track of an assembly, which is your DLL, your game logic DLL, and keeps track of when it was last updated. And it loads that DLL at runtime. So it's got the path where it needs to look for it, loads it up, it finds the game logic class, it looks through all the types in the DLL, finds a game logic class, and creates one. And then if the state is null, so the game state contains all of the state of your game or application. If that's null, it gets a copy of it from the logic, from the game logic class. And then we have update and draw functions, which just pass through to the game logic function. And then we have a set state, and this is what is used if you reload the DLL. So you've been playing the game, state's been changing, you reload the DLL, it gets a new GameLogic class, gets its state from it. Um, right here we get a state object from logic.getState, and this will be the uninitialized state object. And now I need to set all of the things inside of it equal to the old state. So this is the old state, this is the new state, and we set everything. Now you could potentially do this with serialization instead of doing it kind of by hand like I am here. But some of the Monogame objects I'm using, like vector, are not marked serializable, so I can't do that easily. So I'm just doing it by hand here, but you could come up with whatever scheme you want for your own application. Then once we sort of copied everything over, we set the state we're keeping track of to the new state. And the reason you have to do this is when we rebuild the DLL, even with this, you can't just pass our old state object to the GameLogic DLL. Even if it happens to be the same, the .NET runtime knows it's not really the same. It's not happy about it. So we got to make copies of everything. Check DLL just checks the file, gets the last write time, and if it's newer, starts the process over again, loads a DLL, sets the state. So that's basically all there is to it. We use the dynamic feature of C#. So this is going to be the GameLogic class, and this is going to be the GameState class. The way dynamic works, once you've called a function once, it's compiled and remembered. So the second time you call it, it's fast. So the slowness will only happen in debug builds when you first load a new copy of the DLL. A limitation here is each time you add a new assembly, so each time you recompile your GameLogic DLL, there's no way to unload the old one. So it's a memory leak. So if you were going to iterate, hundreds of times in one execution of the program, eventually you would run out of memory. But it's fine for doing, dozens of things, unless your game state is really huge. Or not your game state, but if your DLL is really huge. The other feature we have in here is we're doing the same thing for shaders. So we have one shader in here that we're using here. When we draw our sprite, we apply this shader. So you'll see the guy's kind of blue. So we can tweak this shader. We're just going to change one of the color values. As soon as you hit save, that change is reflected in the program. And the way that works is similar. We are watching the shader files. So we're checking our shaders. We look at each one, see if its update date is newer than what we recorded before. And if it's changed, we have to do some tricky stuff for Monogame. We have to call the shader compiler executable, recompile the shader, do some magic. But eventually we end up with a new set of shaders that we keep track of in a dictionary. So we have shader name to the actual effect class. So whenever you use shaders, you need to get them through that dictionary, and you'll always get the latest one that you've hot loaded. And then some of the overhead for the shader hot loading you can disable by having it be debug only. Right? All this stuff only happens in debug builds, not in release builds. And so that's about it. The main improvement of this way of doing things versus the old way, which used 3 projects, is now you can declare your own classes in your game state without having it be in a separate project, which causes a lot of problems where you can't use methods easily because the class is decoupled from your actual game. So this is much simpler. Performance might be a little bit better too, since we're not calling functions through an interface. We're just calling them directly. So that's it. You can use this as a template to start your own game and be able to redo your code while it's running. One other limitation is if you want to debug, debugging actually works fine, which is cool. So I can put a breakpoint in the game logic and I can hit it and watch everything. Everything works fine. And you can do the same on the platform layer. You can put a breakpoint in, it hits it, no problem. But to do that, you have to do this double Visual Studio approach. So you have one Visual Studio running the program and use a second one to recompile the game logic DLL. And when you do that, you have to hit it twice. Like the first, oh yeah, if you actually change it, you usually have to build twice, then it works. You can also just run the game from the command line, have one Visual Studio open and rebuild, and you don't have that problem. But you won't be able to do the debugging if you do it that way. So that's it, and this is all at a GitHub repo here. It's free to use, so feel free to grab it and play with it. And let me know if you have ideas how to improve the system. Thanks.